All right. So my name is Kevin Lynagh. I'm from Portland, Oregon. This talk is going to be a little different than the Preds, so it's a little more technical. I'm going to be talking about a project that my team just wrapped up using ClojureScript to build some tools for operating heavy industrial equipment. Okay. So this project was kind of cool for a couple different reasons. I mean, one is it involves heavy industrial equipment, which is pretty sweet. This is actually a photo of standing inside of set equipment. So we actually went out to a site in the middle of nowhere, Texas, and we put on hard hats and all this equipment and climbed around and things like this. So it's sort of what Fred was talking about, where you want to spend your time with people who are using your stuff. It's like we built some tools for technicians and site managers and stuff like that. I always think it's funny when I hear about nerds talking about building things for users. There's a joke about there's only one other industry that calls their customers users. So, yeah. It was cool because we did this heavy industrial stuff. It was actually an app on a phone, which is pretty cool. The other thing that I liked is we used functional programming, which is something I think is pretty cool. It's not yet obvious to everyone how cool it is, so I'm going to try and convey some of the coolness to you all tonight. And this is the fun functional programming stuff. I'm not going to be talking about monads and all that. It's not as fun. I like math and stuff, but the other thing that I thought was really fun about this project is we used this these weird hieroglyphics. So it's sort of ancient wisdom to kind of structure our application and think through things and talk with the customer and stuff like that. So I'm going to talk about all these things, and at the end of the day, I'm really a practitioner. So I run a small consultancy. We like to solve problems, make money, go home at 4, drink beers. So I want to try and convey some of that to you, so you can see some of this stuff and maybe use it in your own work, or on your own projects or stuff for fun and all that kind of thing. First and foremost, I'm going to show a little bit of Clojure code, so you'll be able to take some of this and play around with it and maybe get a flavor of it. But to be honest, that's not really the emphasis of my talk. So I'm going to be talking about these broader ideas that you should be able to apply regardless of the language that you're using. So it doesn't matter if you're using Java or C# or whatever. You can take some of these ideas and hopefully apply them in your projects, even if you're not using the latest and greatest computing technology from 1956. And one of those big ideas is, again, this weird kind of, these diagrams for how to think through applications, this idea of what are called statecharts. This is actually from the ancient times, from the early 80s computing. And then the other big idea I'm going to talk about is kind of how you build out an application in a functional style. So if you Google around and you're like, hey, I want to build like an interactive thing, and people are going to click on stuff and things are going to happen, you'll see lots of articles from small talk people about MVC and all this object-oriented stuff, about how you can architect these things. And it's not, at least when I first started doing functional programming, it wasn't as easy for me to find information about, like, how do you do this in a functional way, right? Like, how do you build an application? It's like you can find lots of examples to be like, here's how you can generate Fibonacci numbers in Haskell or whatever. But it's not as easy, to find stuff like, how do you build an actual application that people are going to use, and they're going to click on buttons and it's going to run a phone? Like, how do you do that in a functional language? So I'm going to talk about some of the techniques that we use to do that. And, I really want to motivate this a lot with like the things you can do to sort of sell some of these ideas to your colleagues. So you want to be like this functional programmer, she's super jazzed because she has sold her colleagues on how cool functional programming is. And they're like high-fiving because, they ship their project and they're all going home to have beers. It's great. So that's kind of what I want to focus on for this talk, is that perspective, right? Because there's a bunch of cool nerd stuff about functional programming, but at the end of the day, it's like we want to make some things and solve some problems, ship some product. And there are a lot more people involved in that process than just the developers, right? You have designers and managers and your customer and all that kind of stuff. So outline of the talk, it's in a couple parts. The first thing I'm going to talk briefly about some of this context of this kind of industrial stuff to just give you a background for the thing that we built. And then with that background and that context, I'm going to talk about this theory stuff. So this idea of using state charts to kind of design your application at a high level. And then I'm going to talk about how we actually implemented those ideas in Clojure. So we actually use ClojureScript, which is Clojure compiled into JavaScript. So we use that with React.js on a phone to make like a real app that you can click around and play with. So I'm going to talk about that stuff. I'm not going to get super into technical details. If you want to know all the super technical details, you can come get a beer at the hotel bar with me immediately after this talk. Okay? Okay. Which reminds me, actually, I already have a beer. I don't know if you guys saw it. So, yeah, this is a picture from standing inside of one of these machines, and it's this huge, tens, probably hundreds of tons of like steel. These giant machines are all over the world. Some of them are in very remote places. And basically what they do is they print money, right? Which is pretty cool. Unfortunately, sometimes they break. They'll literally catch on fire sometimes, which is really bad. Other times, you just burn off the oil and things start smoking. And it's not good, right? So Fred talked about the key performance indicators. You don't want them to catch on fire as much. It's because they stop printing money when you do that. So what happens when something like this occurs? There's some technician somewhere. They get a call. They get an alert. They get a clipboard. They get some paperwork, right? They get a wrench. They get a huge American truck. They drive out to one of these things in the middle of the desert, put out the fire, use the wrench, goes back to printing money, right? This is the problem, right? And the issue in particular with this is that they actually needed, this client came to us because they needed a better workflow. There's a lot of downsides of paperwork. A lot of it is, it's kind of hard to sync. They have sites all around the world. When you have all these different procedures and all these different kind of schematics and things, we saw some shit, right? We saw some shit that had been photocopied like 10,000 times, and it's like, how can you read this diagram? Like, I don't, what's going on here? It's also really bulky, so it's actually a lot of work to shut down one of these machines so you can climb inside and start fixing things. And it's not fun to like try and climb inside a confined space with a 3-ring binder, with like 20 pounds of documentation, or kilograms or whatever. Not good. And then they also wanted some tools to do like preventative maintenance and stuff. So when you have forms, kind of at the whim of the technician, or like how good they're feeling that day and how diligent they want to be if they show up and they're, because you might get notes that are just like, things look fine. It's like, it's not very helpful, right? But if you have, a phone or something, you can be like, okay, we're going to have this checklist, and it's like, you need to take a photo of these 5 things, and then we can, put all that in a database, and then the company-wide, like, Gearbox manager or whatever can look at all those photos. So those are sort of the motivating things that this company approached us for, and so this is what we ended up building. It's basically like a glorified to-do list app, so you kind of navigate around these different components, and then you sort of crawl around and rate stuff, right? So you're like tapping on things. You're like, okay, this is clean. Like this is in good condition. This is in bad condition. You might need to take some photos of stuff. This is basically, the app that we built for these guys. And to first approximation, it looks pretty simple, right? It's like a to-do list app. We know how to build a to-do list app. But if you look into it a little more, there's a lot of kind of complex details. I'm sure you guys have worked on big projects, and like the hard part is not giving that 10,000-foot view, but like when it really, gets down to it and you're building it out and you have all these edge cases that no one ever thought of until you build it and you're like, shit. So one example in this project is, right, this is on a phone, and some of these machines are in these very remote places where they don't have a cellular connection, they don't have Wi-Fi, they're in the middle of nowhere. So at a high level, you're like, okay, it's cool, we're gonna build this app, and then like technician logs in, and then they go and they get like a list, and they like, taking photos of stuff. But then it's like, oh wait, like they're in the middle of the desert. Like how do they log in, right? Like they have no internet, and then figuring out all those details is actually the hard part, right? Like should you sync the login for that region so that every technician's login info is on the phone and the phone can decide, or like do they have to log in at the beginning of the day when they're at their hotel or at the site office? All these kinds of things, right? And there's a number of different techniques you can use, right, to figure out some of these sorts of like specification questions and issues, and like how much you do up front, it's a big question. Like the simplest kind of is just, you just have a lot of conference calls, right? Like you get the developers and you get the people who are going to use it, you get the technicians, you get their managers, you all sit down, you're like, how's this going to work? Like what does your day look like right now? And you can start taking notes, maybe you like put together some flow charts. If you're doing like a graphical app like this, we do a lot of screen flows, right? So you're like, I'm going to sketch out what the different screens are going to look like, and you're going to start here, and you click this button, and this thing pops up, and you kind of just draw that stuff out. you're building up this massive sort of specification. Another one's it's like user stories. You go interview people, and you just kind of make up these stories. You're like, Ted the technician wants to go do X, Y, Z, and this kind of thing. I know a lot of developers are really keen just to prototype. So you throw something together, you give it to them, and you're like, cool. How does this work? You get some feedback, right? It's kind of delivering quickly, seeing what goes on. And these are all good things to try for doing specifications. There's all sort of a place for them. One thing that I kind of ran into when you're looking at doing this stuff, and what kind of bugs me with a lot of these in some ways, is that they're all kind of informal. So if you have a really experienced team, you can get by with it because people have all been burned by something in the past, and so that person's going to speak up and be like, oh, in this flowchart, we need these extra things because we totally didn't see this coming, or in the user story, you're like, no, trust me, this person's going to do X, Y, Z. But that can be kind of hit or miss sometimes. And in particular, I was interested to see what are sort of more formal specification techniques that you can use besides having a pile of prose, right? A user story is great, but then they aren't necessarily they're not always complete, right? So you can have a user story of Ted the technician logs in and they choose the project they're working on, and that sounds fine. But then you think about it some more, and you're like, well, that said nothing about Ted having internet or not. How do we resolve these details? And oftentimes you just figure that out when you're building it. So I was kind of looking into this stuff, and this is sort of what led me to this idea of Harel statecharts, which is this formal specification technique, which I think is really interesting, and it's actually a lot of people in the embedded world use it. We used it on this Android project. We're also using it right now on an embedded project with a 6 megahertz microcontroller. So it's kind of this general technique. It's not specific to any particular language or tech stack or anything. And this problem is not new. So this is a picture of this guy, David Harel, and back in the 80s, he was a new associate professor in Israel for math and computer science or mathematical logic or something. And he got this pretty cool gig where I think on Thursdays he would go hang out with this consulting company, this computing consulting company, and they had this project where they were actually building out all this avionics software for this jet fighter, right? Which is pretty cool. And Harel does not know about jet fighters. He's a math computer nerd, so he's just showing up on Thursdays and hanging out with these guys to try and help them figure out stuff. And what ended up happening is they had all these specifications, and they'd read through them and he'd see what's going on. And he basically just played this game of 20 questions where Harel, the new guy, this math guy, would sit down and he'd be like, okay, so what happens when the pilot presses this button? And then what they would do is they'd pull down all these binders, and they'd pull one of them and they'd be like, okay, binder 3, subsection A4, when the pilot presses this button, the plane is going to do this. And then Harel would go, okay, well, what if the plane is parked? And they're like, oh, if it's parked, and you press that button, and they pull out another binder, and they're like, well, so right here it says, and the plane's parked, and you press this button, this other thing happens, right? And so it kind of plays this game of 20 questions, and they go back and forth with these binders, but then after the fourth or fifth question, his client would be like, we got to call the Air Force, I don't know. And so they'd call up the Air Force, and they'd ask the same questions. And then, by the 8th or 9th question, the Air Force would be like, we don't know, right? We looked at our binders, and we really have no idea, what's supposed to happen, right? And so, he's doing this, over the course of a couple months, and what he ends up doing is he starts drawing all these little diagrams, right, because he's a computer science guy, in the margins of all these documents. And, so how many people here are familiar with finite state machines, finite automata kind of stuff? Yeah. So, it's kind of like that. He quickly notices that there are these different states the plane can be in, right? The plane can be parked on the ground, it could be flying, and then there are also, kind of substates. So in traditional finite state automata, you just have states and transitions between them. But he's drawing these diagrams, and he really wants to have kind of substates, because it's well, when you're flying, you could be doing, you could be shooting at stuff, you could be being sneaky, there are these different substates that the plane could be in. And so he's drawing these diagrams and kind of, figuring out what happens when you're in this state and this substate, and this event happens, you go over here, and he very quickly, they all start talking over these diagrams, right? They put the binders aside, and they're all talking about this. And he has this great story where one day, they have all this stuff up on a whiteboard, right? And they're all talking about it. And then this pilot comes by, right? And the pilot's like, what's this? And they're like, oh, well, there are these states, and these events happen, and you go from here to here, and you follow these arrows, right? And the pilot's looking at it, and then after 2 minutes, the pilot's like, okay, down here, I think this needs to go over here, right? And he was right, which is amazing. That's an amazing testament to good notation, because I don't care what programming language you're using. There's no way in hell your customer is going to walk by and look at your code and be like, I don't think this is right. That's just not going to happen with code. And that's one of the things that's really cool about these state charts is that you have this kind of map or this visual formalism. And Harel is a mathematical logic professor, so of course after this project he writes a paper about it and defines formal semantics, which is great. And this is actually a super readable paper, right? This is from 1987, and I highly recommend looking this up. So he basically defines the behavior of his. He has a digital wristwatch, with all the buttons, and you can set alarms and make it beep and all this kind of stuff. So he builds out this state chart describing how the watch works. And so it's a super readable. I don't read mathematical logic papers a lot, but this one's super readable, and there are all these cool pictures and stuff like that. I found that they're a really useful tool because they have a formal semantics, and you can actually implement them in code, but at the same time, you can show them to regular humans and be like, hey, does this look right? Here's what's going on, this is what we think you mean. And you can have conversations with designers and customers and stuff like that. So to give you an example in maybe a more familiar context, I don't know how many people have worked on jet fighters here. I'm just going to walk you through a simple state chart just to give you a flavor of what it looks like. And the example I'm going to use is just a login flow, right? So you have an app, you need to log in before you can get inside, do some cool stuff in the app. So you start, you just draw out and think about the states that you have, right? So you might have a login state, so we're just indicating that. It's like a draw box, you name it. And so this is the start state, so the person's going to start here. So we indicate that with a little arrow like this. And if you think about it, conceptually, there's only really one thing you can do on a login screen, which is you can submit some credentials to try and log in, right? And for anyone who's implemented this, you don't actually go straight into the app when this happens, right? You actually sort of go into this intermediate state where maybe you've communicated those credentials to the server, but really your application is waiting. You've grayed out some boxes and you have the spinning wheel or whatever, and your person's waiting. So you're in this kind of logging in state, which is a little different. And then at that point, maybe the server gets back to you and it has this new event for you. It says hey, your credentials are valid. Congratulations, you can go inside the app. But alternatively, right, your credentials might be invalid. You go back to the login screen, or maybe after 5 seconds, your local app gives up on the server and sends someone to a timeout screen and it says sorry, the server's down, try again later. So this is a really simple example, but already having a little picture like this, I find much clearer than just a spec, a written spec. And again, the thing that's cool about state charts is that it's not like a finite state machine where all the states are at the same level. You can have this notion of hierarchy. So to bring it back to the example of technicians using this inspection application, you could say actually, that at the very high level, we want to design this app and say you're either online or offline, right? And maybe we only want the login flow to work when you have an online connection, right? So you could shrink that down and say okay, you're either offline or online. You're going to start in some offline state, and then at some point you might get a connect message. At another point you might get a disconnect message, and you would kind of read this diagram in hopefully a way that seems somewhat natural, right? So if you're in the offline, oh, you can't see my little pointer. If you're in the little offline state, you can connect. You go inside the online state, and since that has substates, you kind of recurse into it, and so the default state in the online state is you start at the login screen, right? And at any point in any of those states, if you get a disconnect message, you're getting sent back to the offline state. So, this is kind of a nice thing because it lets you kind of hierarchically decompose the behavior of your application and kind of think, it helps. I mean, for me, having to think abstractly about the states before you dive into the code is really nice because you can draw these little diagrams and talk with your client, and it's easy to communicate and convey that kind of stuff before you get into all the really nitty-gritty details. Like I said, there's actually a bunch of literature in the embedded world. I don't know why, I guess web people, we're all graphic design refugees or something, so we have no idea about engineering in JavaScript. But if you want to learn about some of this stuff, there's a great book for how to actually implement this stuff in C and C++. So it talks about the semantics and kind of how you would build this stuff out. So that's kind of the theory. How do we go from this diagram that I drew in Keynote to an actual kind of application? Like, how would you put this stuff together? I'm going to talk about how we did this again with Clojure, and we did it with HTML5, and this is all kind of like a little web app running on the phone. But again, that's an implementation detail. You can take these ideas and use it whatever language you're using. So I really want to underscore that. Before we get into the Clojure stuff, though, I want to, I'm going to show you a couple examples of code in Clojure. I'm just going to give you a quick 101 of the Clojure syntax and stuff. There's not going to be any monads. All right, so in Clojure, this is what function application looks like. So this is a list of 3 things. First thing is plus. And so since it's the first thing in the list, it gets kind of invoked as a function. These are the arguments. This is what you get out. That's how function application works in Clojure. That's it. There's no infix and prefix and methods and all this kind of stuff. It's just this guy. The other thing that's nice about Clojure is that it has explicit data structures. In Clojure, commas are white space, so you'll see them sometimes. Sometimes you won't, but they're white space, so you can fill them in with commas if it makes you feel better. This thing at the top is just a vector, so it's kind of like an array. It's a list, sequential collection of things. They don't have to all be of the same type. And then underneath that, we have a map, right? A map or a dictionary or an object, depends what language you're from, what you call that, but it's a collection of key value pairs. And these things, there's explicit syntax for them, and they evaluate to themselves. So that's nice. That's all the Clojure you need to know for the rest of this talk. So there's functions, there's maps, there's lists. It's good. So how would you actually implement this? The way that we did it is we actually kind of decided to say, if you look at these states, in this particular case of this application, all these states kind of correspond to screens in the application, right? It's like there's a login screen, and then maybe we have a different logging in screen, there's a sorry screen, there's our other applications. So what we can do is actually associate each one of these states with a template, right? So just some function that's going to get invoked when the machine, like the system is in that state, and that function is going to give you the UI that you want, right? So this is what a login screen might look like. If you kind of squint, it looks a little bit like HTML, right? So it's like, okay, we have a div, there's a header, there's a form. It's got some inputs for you to type your username and your password, stuff like that. So yeah, right. This is just a plain Clojure function. There's no weird mini templating language or anything like that. This is just a function that returns, right, like a vector with some other vectors and maps and stuff inside it. So this is just some plain old data stuff. And if you squint, it looks like HTML. And what's kind of cool is on this the form on submit callback. So whenever someone presses enter or they press the submit button, this function is going to get called, and the function is getting passed in as an argument. So that's some functional programming stuff. And it's just going to get called with this string, submit credentials, and then this username and password, right? And this is exactly what we've modeled in our little picture, right? This is the name of the transition, the event that's going to happen. So it's actually like figuring out how to draw this stuff out is kind of the hard part, right? Because you're defining what your application needs to look like and how things need to behave. But then once you have this diagram of the states and how they relate, it's actually pretty easy to like write up the rest of the application. And what's cool about functions is that you can invoke them multiple times, right? So there's some nice things. You can use them as a method of abstraction, things like that. So if you think about this, like the logging in state is usually really similar to the login state. Like it's basically the same thing, but you like gray out the boxes and like add the spinner or whatever. So if we want, we can reuse that same template in here. So this is basically the same. I've added some things, so I'm going to highlight that. We're passing another argument, which is the name of the state. So that's either going to be login or logging in. And then down here, we're just saying, hey, when you're in the logging in state, I'm going to say disabled true, right? And then down here, I've changed the label, so instead of saying login, it now just says the state. So it'll say either login or logging in on the button, right? So this is just kind of standard, hopefully, like programming stuff. It's like we have a function, we want to handle two different cases, like we're going to use an argument to the function to like handle how we're going to do that. And that's basically it, right? Like, in this case, we're just using our functions as templates. And then from that, you get reuse and abstraction from functions. I don't know how many people have used, like, AngularJS and Backbone and all these things. Like, all these people want to make these weird templating languages that are, like, not really languages, but, like, sometimes if you put curly braces in, things happen. And, like, sometimes you can, like, iterate over things, but not really, and it's not the same iteration as, like, in your regular language. I don't know why people do this, because it's just this whole set of half-baked semantics. Like, it's like, if you want to, you know, have a template for something, like, you have something that you want to reuse, maybe vary like a couple parts of, like, you could write a function. Like, that's called programming. Like, it's not even called functional programming. It's just, call it a method, right? Call it whatever you want. Right, but, you know, that's a nerd thing. So I wanted to focus on things you can take home from this. And again, the great thing about functions is it turns out designers actually really love this because you can call functions multiple times, right? And I don't know about you all, but like the head designer that I work with, he has one of these like massive Apple monitors. It's like this huge, and we're making a mobile app, which is this big, right? So he'll oftentimes when he's doing the design stuff, he will call the function a lot and just make a bunch of versions of each screen, and then he will use the arguments to the template to like vary it, right? So you could call this login template and see like, hey, what does it look like when like someone has a long name and a short name and their password's right and their password's not right, and like, you know, you can put all this stuff in here and show them all on the screen, and then they can mess around with CSS or whatever, right? And make sure that he's not like breaking some edge case of like when the username is wrong and the password is wrong and they're both red, like the flow gets all broken or whatever. Like he can mess with all that stuff, right? And this is a huge win for designers because, you know, they can just reach in and say like, okay, this is what I'm working on. I'm going to just grab this function. I'm going to call it. I'm going to see what it looks like. I'm going to work on that. You know, it's really nice. And the other thing, you know, that's kind of nice again for the developers is I can't really. It's hard to underscore this enough. Like, but like functions are really nice. You know, they compose in these nice ways. So. This is an example. This code is like the little widget that's getting clicked on. So this is basically polymorphic depending on the kind of observation you're making. So depending on the equipment and stuff, it's like you might need to say this is a true-false statement, or like this is a drop-down list, or like this is going to be numeric input, things like that. And so here, you know, it's like here's the list item. You know, we have some things that are coming on in here. But like we, you know, this observation point selector, this is like another function that we're calling, right? And so we can like break things apart into like small enough pieces that make sense and kind of work with all these kinds of, like, you know, here like the photo icon, there's actually a bunch of markup there because like when you click it, there's like a drop down menu and it has these different handlers for if you tap it or you long tap it and stuff like that. We can encapsulate all that stuff into a function and then we can just call it where we need it, right? There's none of this weird, like, we have these weird nested templates and like we don't know where things come from and like we don't know how to nest them together. It's like you can do all this stuff with functions and like data. It's really nice. So, you know, functions are really nice. It's just like you don't have to use Clojure or Ruby, or you can do all this in Java, right? I write really weird, like functional Java, which is just like you have a lot of static methods and you return values and you just put them together, and it's fine. But what's kind of interesting is, you know, you can take this idea much further, which is that like, okay, well, we made each screen as a function. You know, you kind of nest these things together and stuff. And what you can do is you can make your entire UI as a single function, right? Like you can turn this up to 11 and like really run with it. And there's actually a name for this, which is called like an immediate mode UI, which is basically you have this render function and it renders your entire application, right? As a function. So it's calling all these things, and at some point, you know, you call this render with something, gives you this big pile of HTML, and that's what's on the screen. And it sort of raises the question, like, what's this guy, right? It's like, that's the state of your application. It's the entire state of your application. It's right there. And a bunch of nice things actually fall out of having an explicit state for your application, right? So if anything changes in your application, like if you open up a menu or something, this needs to change a little, right? Because the entire application is getting rendered from this state and this function. And you can, you know, model this in a lot of different ways. Like in some ways you can just have like a map, you know, you can have a nested map of all these different details and stuff like that. On this particular project, we actually used a immutable graph database on the client, but that's a beer talk. So, we can talk about that more later. But there's just a bunch of benefits from having the application state be explicit. You can have a single reference to it. And the first and foremost is that it's viewable, right? You could print it to the console, and you can be like, why does my application look like this? And you print it out, and you look, and you're like, oh, okay, here's the data for the application. Here's the function that is going on. You can figure out what's going on. That's a developer thing. Another case of where this is actually really cool outside of just development life is that if you have explicit application state, you can serialize it, which means that when someone's in a big truck in the middle of desert and your app breaks, you don't have to play this weird phone tag game with them where you're like, okay, you're on the home screen, and then you click on something, and then you take out your phone and you click on it, and you're like, and then what do you do? And you click on that, and you kind of, it's you can actually just say, this thing is broken, we're going to serialize the entire application state and submit it with the bug report. And then you can just get that and you can play around with it, figure out what's going on. This is a huge win, right? Because it sucks having that conversation. No one wants to spend all their time trying to synchronize this application state over a telephone with two humans in the middle. Just serialize it and look at it using computers and stuff. The other benefit of having explicit application state is that it actually makes your application reloadable. So if you have a handle you have the entire application in this nested map or whatever, you can reload instead of, you can redefine your application and rerun it against that state. And this is super handy in development, right? So again, kind of coming back to making the lives of designers easier, a lot of the designers that I work with are really OCD, and which is good. It's a good thing to have in visual designers and stuff. Right, but it's you have a 5-step wizard. You enter some data, and you go to the next step. You enter some data, you go to the next step. And then in the 5th step, it's whoosh, it disappears off the top of the screen. And the designer will be like, that animation looks wrong, right? And it really sucks for them if they have to reload the page, go through the 5-step wizard again, right? And then they change the CSS to go through the 5-step wizard again. It's whoosh. And they're like, now it's too slow now. Or that was too fast now. It's a terrible experience. But, if you have this reloadable application state, you can rerun the application on the exact state that you were. You don't have to recreate it by clicking on all the buttons and all this kind of stuff, right? Another thing that falls out of that, and this is sort of related, is it's really easy to implement undo because you just hold on. You basically have, your application state. Someone clicks a button. Some event happens, you use your state machine or whatever to make a new version of the state, and then you kind of step through that. You can hold a little handle to the previous application states, and then if you want to undo, you're just okay, let's just go back to the last one, right? If you're doing all this stuff with, a bunch of side effecting code and, all these things happen in callbacks and everyone is mashing on the DOM and all this stuff, you can't undo that, right? You have to know everything that happened and hope that you can reverse all of it, which is really hard. But if you have the entire application state I could hold, you can get the previous one and just roll back. And so even if you don't expose this to your users, we actually expose this in it's an Android phone, right? So we can just use the back button. So every time you go back, it actually just undoes what you did previously. That took 10 minutes to implement undo, right? It's great. But even in development, right? So with the designer with their little whoosh modal, they dismiss it. They don't like the animation, they can go back to the previous state right before they dismiss the modal, change CSS, keep playing with it that way, right? It's really nice. Okay, so, to wrap up real quick, specs are tricky. These things all have their place, and, I just kind of wanted to use this talk to talk a little more about state charts. I think it's a really cool idea. Even if you're not into the crazy mathematical logic side of it, it's just the sheer fact of thinking in advance, what are the states our application can be in, and how do people move around between that, will help you have a much better design, having to think about it explicitly rather than kind of muddling through while you're building out the code. And if you do model that state explicitly, you can really write your application as this functional thing. You can have this big transition function that encodes your state machine. You have the state of your application, and then whenever you have some event that happens, you get a new state of your application. And then from that state of your application, you have this render function. That's how you render your application, right? And having an explicit render function is nice. You get all this reuse that I talked about with being able to build out templates and all this kind of stuff. It's easy to compose. It's very easy to test. We can do really easily like visual testing, right? Of just like, here are the different templates that we have. Here are the different options they take. We're just going to call those functions a bunch of times, see what things look like. And then, when you have explicit data, it's great because you get this introspection, you get this serializability, you can reload, you can undo, all this stuff, right? And all these things are possible. You don't have to use Clojure. You don't have to do any of this fancy stuff. You can do all this stuff today in JavaScript. It's a little harder, but you can definitely do it. And if you start playing around with some of these ideas, playing around with some of the functional programming ideas, you can really get some of these nice benefits, which is going to make your life better as developers, but also hopefully make the lives of the designers and the client and all that stuff better. And then hopefully you can take this and make some cool stuff. Thanks.